Hi everybody, it's Donna the astronomer coming to talk to you about exploring our solar system, some fun facts and figures. Today we're going to talk about Mercury, but before we get to it, we're going to do a little bit of an introduction. On the front page here, we have a scale model, thanks to NASA, of the Sun. You can see a little bit of the Sun, the 4 rocky planets, Mercury, Venus, Earth and Mars, the 4 gas giants, and they're big: Jupiter, Saturn, Uranus and Neptune, and the little dot over the far end is the dwarf planet Pluto. I've left him in there just to give him some context. So this is the Sun. The Sun is big. The Sun is known as Sol in Roman and Helios in Greek, hence we have solar system, the system that belongs to the Sun, and Helios for heliocentric. That is that the Sun is at the centre of our solar system. And here you can see how small everything is compared to the Sun. You can put 1.3 million Earths inside of the Sun. That's a few Earths. If you put 109 Earths side by side, would stretch across the Sun. 99.85% of all the mass in the solar system is in the Sun. That doesn't leave a lot of mass left for the planets, does it? The Sun is 150 million on average kilometres away from us. That's called an AU, an astronomical unit, and that'll come in and out of our talks as we go along. But let's look at some distances and travelling. Now, we understand driving in our cars between, say, Sydney and Coonabarabran is about 6 hours. So if you drive at 100 kilometres an hour, you might get to Katoomba in an hour, you might get to Mudgee in 3 hours. But let's see if we wanted to go a bit further. What say we wanted to go to the moon in our little jalopy? See, they're flying through space. If you could drive to the moon at 100 kilometres per hour, a distance of roughly 400,000 kilometres, it would take you 4,000 hours or 166 days and 14 hours. Not too bad. But what if we wanted to go further? Because space itself is really, really, really big. What if we want to go to the Sun, 150 million kilometres away? Okay, it would only take us 62,500 days or more than 171 years. And most of us at the moment don't anticipate living that long. But how about let's go to Pluto? It's only 5.2138 billion kilometres away from us, and it would only take us 59,477 years. And of course, it took over 10 years for New Horizons to get there. So we probably won't get there. By the way, if you wanted to go to the Sun in a jumbo jet, it would only take you 17.5 hours. So here we go, the inner planets, of which our mate Mercury is one. Okay, so there we go. There's Mercury, Venus, Earth and Mars. We're going to have a look at a couple of definitions because we need them as we go along. We're going to talk about a rotation, which is a day. That's the time a planet takes a spin on its axis. On the Earth, it's about 24 hours. An orbit is a year. That's when we have a birthday, the time it takes to go on our journey around the Sun. And for us, that's 365.25 days. And eccentricity is the variation of orbit around the Sun, because the orbits of the planets aren't circular. They're more slightly egg-shaped, more eccentric. Some are more eccentric than others. In fact, Mercury has the most eccentric orbit. Its variation between its distance between it and the Sun can go from about 48,000 million kilometres to around 70 million kilometres. So, and of course, if you go out as far as Pluto, it gets totally and utterly crazy. But we'll talk about Pluto when we get to Pluto. So they're just a couple of definitions that we need. But the bottom line is space is really, really big. We're going to talk about Mercury. Here's our little fellow off flying there. It's only 95 million kilometres from us, 55 from a million kilometres from the Sun, roughly. You could drive there. It would only take you 108 years. I'm just sort of thinking what you'd eat on that time. So here is Mercury. Looks a bit like the moon, doesn't it? All those craters and everything else there. Very, very interesting planet. It has no atmosphere because it's so close to the Sun that such things have already burned off. It has an iron core. In lots of ways, it's very similar to Earth. Ganymede, the largest moon in the solar system. It's one of Jupiter's 4 Galilean moons, and Titan, the largest moon of Saturn, are actually bigger than Mercury, which makes Mercury pretty little. It has no, it has a magnetic field, but it doesn't have any moons of its own. It's an interesting planet because it's so close to the sun. You'd expect it to be the hottest planet. Makes logical sense, doesn't it? But it isn't. It's actually the second hottest planet, with Venus taking that record, and we'll talk about it next time. But Mercury is also one of the coldest places in the solar system, as we'll talk about. Now, Mercury has been able to be seen for millennia. It's been able to be seen without need for a telescope. Like we said, like we can go out in the morning sky and see it low on the eastern horizon. So the early ancient civilizations saw it. They noticed that it switched between the morning and the evening star. Now, they probably didn't realize it was the same planet, so it was given two names, as was Venus as well. It was known as Nabu to the Assyrians. It was known as Hermes to the Greeks, and Mercury to the Romans, and that's the name that it's kept to this day. So no one can actually take the credit of seeing it. Even Galileo, when he first looked at it in the 1600s, the earliest 17th century, he didn't actually notice that it had phases. Now, the one thing about Mercury and Venus, because they're between us and the sun, they actually have phases similar to the moon. And at the moment, both Mercury and Venus have got phases, and the brighter they are, the less of the actual planet we can see if we look through a telescope. And you can see it quite easily in a small telescope or a good steady pair of binoculars. If you're going to look at it in binoculars, just so you can see some of that, you probably should put your binoculars on a tripod, or get them on something very steady, because your hands tend to wobble and it makes it more difficult to see. But it's worth having a look at, and it's very interesting. So it was named after the messengers of the gods because it travels so fast around the sun. It's the most cratered planet in the whole of the solar system. And more interestingly, its gravity is much better than the Earth. So I like it. If I weighed 100 kilograms, which I don't because I weigh more, but if I did weigh 100 kilograms on Mercury, I would only weigh 38 kilos. I think that that's a good thing. So that's one thing about it. The whole surface of Mercury has been mapped by the Messenger spacecraft, as we'll see in a few bits. It's believed that Mercury has a tail, and just like a comet does. So there's basically streams of particles that have been, I guess, sloughing off its surface, basically coming off its surface because it's so hot and so close to the sun. It's been seen, as they've done some observations of it during transits of Mercury and things like that. These transits of Mercury occurs about 13 times every century, and we missed the last one in Australia because it wasn't visible to us. It happened during our evening. So Mercury is about 50% larger than our moon, because our moon's pretty small. It would take 18 Mercuries to match the Earth, and because Mercury isn't tilted, it doesn't have any seasons. So it's a very interesting planet. Now, I was talking about how it's not only one of the coldest places in the solar system, it's one of the hottest ones as well. And did I tell you it travels at 47 kilometres per second, which is pretty fast. I wish I could even go 49 metres per second, it'd be handy. Okay, so its axis has the smallest tilt of any one in the solar system. So this is Mercury, it's only 1/30th of a degree tilted. Earth's 23 degrees, Mars is 25 degrees, Uranus is 90 degrees, knocked over. And because of this, the north and the south poles of Mercury don't get any direct sunlight on them. And in the craters there, Messenger reported that there's water ice and carbon, some sort of coal tar sort of device, which makes it very unpleasant. So the temperature on the surface can get around the 427 to 430 degrees Celsius. And in the coldest part, it can drop at night times to about 180 degrees Celsius. The other thing is there's no atmosphere to hold the heat as well. So on the side that's night, away from the sun, similar to the moon in that it has no atmosphere as well. It's colder on one part when the sun's not heating it up. However, I very much doubt that it would be possible for anything to actually live there. So, some interesting bits and pieces. Did you know stuff? Let's go look at some more pictures. So this is a comparison to show you the sizes of Mercury, Venus, Earth, Mars, and good old Pluto down there. Mercury's twice the size of Pluto. Here's our little cratered planet. Because it has no atmosphere, it was bombarded very, very early on. It almost looks like the moon if you don't know what you're looking at. Okay, so here's some basic details. An orbit, which is a year, is 88 of our days. Rotation, 1 day on Mercury is equivalent of 58.5 days on Earth, which means that for every 2 years, there are 3 days. So you're not going to have a lot of birthdays if you live on Mercury. And there's the temperature variation, and as I said, it's visible in the morning sky. That little crater there, isn't that spectacular? You could fit the whole of Queensland in that crater. It's on the North Pole. It's got water ice in it. Because it's quite deep, you've got a lot of shadows and it never gets direct sunlight. And these are pictures taken by the Messenger spacecraft. This is one of the first spacecraft that visited it back in 1974. It was a flyby by Mariner 10 on its way. It shows you there this great big crater, or this great big fault line, which I'm sort of pointing at the picture, which you can't actually see, which is pretty silly even for me. And you can see that even after the ridge line, there have been craters. So it's called the Antonadi Ridge, and it's over 450 kilometres long due to the impact by the things. So this is Mercury from Messenger. Messenger was this amazing spacecraft that was up there. Some more pictures by Mercury, and the colours are just showing geological features and what Mercury is made up of. So it launched in August the 3rd, 2004, entered orbit around Mercury in 2011, took over 250,000 images, and it basically ran out of fuel. So spacecraft have 2 types of fuel. It has propellant and it has the fuel that basically enables the instruments to work. And it ran out of propellant fuel. And so what they decided to do was, after they made various adjustments and it was inevitable it was going to crash, they controlled crashed it into the surface on April the 30th, 2015, and gathered data all the way down as it landed. So even though it was crashed into it, it gathered data the whole way. So that's not a bad pile of work to have done. 4 years, 250,000 images. And here are some up-close pictures of it, showing the details of the craters, and the colours, as I said, represent various elements and things on the surface, what they're made up of. So I'm going to finish now with a few fun facts and figures. Let's see, what do I know? You could fit 21 million, I'm reading this because I can never remember this number, 21,253,933 Mercury inside of the sun. Pretty amazing, isn't it? If you're on the surface of Mercury, the sun would appear 3 times as large as it does when viewed from Earth, and the sunlight would be more than 7 times bright, and you would need pretty incredible sunglasses. Okay, here's some other things. Modern Chinese, Korean, Japanese, and Vietnamese cultures refer to the planet as water star. And I believe that's because it's seen to be rising above the water. Mercury and Venus both never get very high in the sky, and that's because they're what we call the inferior planets between us and the sun, and we don't see them. They don't travel along the ecliptic line as do the other planets. In ancient China, Mercury was known as the hour star, being associated with the direction of the north. In Hindu mythology, they used the name Buddha Gaha to refer to Mercury. This was the god was thought to preside over Wednesday. The god Odin, or Woden, of Germanic paganism was also associated with Mercury, and that's where Wednesday comes from. I think it's apt, it's Wednesday, and we're talking about Mercury. Maya people represented Mercury as an owl that served as a messenger to the underground. And it's one of the few planets that can be seen during a solar eclipse. So that sums up our very first talk on Mercury. Again, if you have questions you want me to answer, there's my email at the bottom, donna@donnatheastronomer.com.au. Leave a message on YouTube or send me a message and I'll try and answer your questions. Next one of this series, we'll look at Venus, our evil twin sister. Thank you very, very much for joining me. And this is Donna the Astronomer signing off.